In the last session, we saw how to solve linear differential equations of order n with constant coefficients. But we looked at it more as theoretically. So now let's actually solve some problems. Okay, let's say the equation is d square y by dx square plus 3 dy by dx plus 2y is equal to 0. Now in our d notation, this would be d square plus 3d plus 2y is equal to 0. And the auxiliary equation would be m square plus 3m plus 2 equal to 0. And this we know how to solve. M square. Now 2 ones 2, 2 plus 1 is 3, 2 ones 2 is 2, so 1. So which means the roots m1 equal to 1 and m2 equal to 2. So m1 or m is equal to minus 1 or minus 2. So our solution of the equation would be y is equal to c1 e to the power of minus x plus c2 e to the power of minus 2x. Second problem, d square y by dx square plus minus 7 dy by dx plus 12y is equal to 0. Again in d notation, we would have d square minus 7d plus 12y is equal to 0. And the auxiliary equation would be m square minus 7m plus 12 equal to 0. And the solution would be m 4 3 is 12, 4 1 is 4, so 4 3, minus into minus plus, minus plus minus is minus. Okay, now which means m is equal to 4 or 3. So we have two roots. So the solution would be y is equal to, again, distinct and real roots. So it would be c1 e to the power of 4x plus c2 e to the power of 3x. Okay, let's look at the next problem. D cube minus 6d square plus 11d minus 6y equal to 0. Okay, it's given to us in d form. So using d notation, so let's directly write the auxiliary equation. M cube minus plus 11m m cube minus 6m square plus 11m minus 6 equal to 0. Okay, now let's try to figure out one root using hit and trial. So let's put it as, usually we start off by saying let m equal to 1. If m is equal to 1, let's do the substitutions and see whether it works. 1 minus 6 plus 11 minus 6. So this becomes 12 minus 12 equal to 0. Okay, great. So which means m equal to 1 is a root. That means we can get another root by dividing this by m minus 1 equal to 0, by dividing it by m minus 1. M cube minus 6m square plus 11m minus 6 divided by m minus 1. So square m cube minus m square. So subtracting, we get minus 5m square plus 11m, and now we multiply it with 5m, we get minus 5m square plus 5m. Subtracting, we get 6m minus 6 times 6m minus 6. Okay, so which means this m cube minus 6m square plus 11m minus 6 can be written as m minus 1 times m square minus 5m plus 6 equal to 0. Now let's factorize this as well. So m minus 1, and here we get m square, and this would be minus 3 minus 2, 3 to 6. Okay, so which means the roots are 1, 2, 3. So our solution would be y is equal to c1 e to the power of x plus c2 e to the power of 2x plus c3 e to the power of 3x. Okay, let's look at the next one. B square minus 6t plus 9 y is equal to 0. Auxiliary equation, m square minus 6m plus 9 equal to 0. Okay, that means this can be written as m minus 3 square equal to 0, and that means repeated roots. So m is equal to 3, 3. Now we know in case of repeated roots, the solution would be y is equal to c1 plus c2 x to the power of 3x. Now fifth one, b4 plus 2b cube plus d square y is equal to 0. Again, auxiliary equation would be m4 plus 2m cube plus m square is equal to 0. Now let's take common out. M cube plus 2m square. No, m square, let's take it out. So which means let's take out m square common. So we are left with m square plus 2m plus 1 equal to 0. This can be again factorized into m plus 1 plus 1. So which means the roots are, remember this again, m square can be written as m times m. So which means this involves 2 more roots. So 0, 0, 1, minus 1, minus 1. Okay. So now here we have two sets of repeated roots. So 2 pairs of repeated roots. Therefore, solution is y is equal to c1 plus c2x e to the power of 0x plus c3 plus c4x to the power of e to the power of minus x. c1 plus c2x, this becomes e to the power of 0, which is 1, plus c3 plus c4x e to the power of minus x. So that is the solution. Okay, let's do the sixth one. d cube y by dx cube minus 2d square y by dx square plus 4dy by dx minus 8y is equal to 0. Now the auxiliary equation would be m cube minus 2m square plus 4m minus 8 equal to 0. Yes. Now we need to factorize this. How do we factorize this? Again, let's see. M is equal to 1. Let's say M equal to 1. If M equal to 1, this will be 1 minus 2 plus 4 minus 8. Now this is not equal to 0. Okay, let's say M equal to 2. In that case, what happens? 2 to the power of 3 is 8 minus 2 square is 4 times 2 is 8 plus 4 times 2 is 8 minus 8, and this is equal to 0. So that means we can factorize this into M minus 2. But to get the other factor, let's divide this by M minus 2. M square, M cube minus 2M square. Let's get 4M minus 8, and here we get plus 4M minus 8. So x, not x, M square plus 4 equal to 0. Or we can say M minus 2, M minus 2 is equal to 0. M square plus 4 equal to 0. That means M square is equal to minus 4, which means M is equal to plus or minus square root of minus 4, which means plus or minus 2i, and in this case M is equal to 2. So we have got the roots as 2 plus 2i minus 2i. So the conjugate pair of roots we have got. Okay, so the solution would be y is equal to, the first is real, so this would be c1 e to the power of 2x plus, then you have conjugate pair, so c2 cos 2x plus c3 sin 2x times e to the power of 0x. Now from where did the 0 come? The real part of the conjugate part. It doesn't exist, so 0. So just simplifying this, we get e to the power of 2x plus e to the power of 0, so 1. So we are left with cos c2 cos 2x plus c3 sin 2x. So that is solving linear differential equations of order n with constant coefficients. That's it for today. Bye for now.